this is a dashed region, and a dashed region means it is not included in the solution. If you see less than or equal to or greater than or equal to, it is a solid boundary line, and that means it is included in the solution. Okay, so the first thing then that I want to show you are half planes. So half planes are basically going to be things that are cut in half just by one line. So you might see vertical lines. So I'm going to just show you the graph of x is greater than or equal to -1. And we're not going to use our graph paper to do this. We'll just sketch it here because it's just a vertical line. All right, so x equals -1 is a vertical line. So to graph x is greater than or equal to -1, I actually first have to graph the line x equals -1. So I graph it and I make it solid. Why am I deciding to make it a solid line? Because it's greater than or equal to. That means in a second when I shade, it is going to be included in the solution. Typically what I tell students is you test a point. So when you test a point, like let's say the point 0, 0, 0, 0 is on the right of the line, agreed? So if 0, 0 works, then I am in the correct area, so I'm going to shade that area. Now, in half plane, some people can just kind of figure it out. Like, where is greater than -1? It's probably over here. All right, but I'm going to test my point anyway. 0, 0 is an x and a y, but I don't see a y, so I'm going to just put x in. Is 0 greater than or equal to -1? Is that true or false? True. So I'm going to shade the half plane that's on this side. What that means, guys, is anything in this shaded region is a solution. That's why we do it with a graph. So an inequality just doesn't have one answer. It has an infinite number of answers. All right, let's do another one right next to it. Graph the solution to y is less than 2. Alright, if I'm quick doing a sketch of this, this is a horizontal line at 2. That's my boundary. I am going to make it dashed. Okay, hopefully you can see that that's dashed. And then where should I shade? Below the line. Okay. Is this coming back to you? So let's do one more half plane on this paper and then we'll move on to systems. If I asked you to graph something in slope-intercept form, y is greater than or equal to 2x plus 3. I'm going to just do a scale of, well, I guess I could do 5s. This is fine, but when we do like 2 of them, that's why we'll use the graph paper. Actually, and I know that they're doing this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You might have even done this in pre-algebra, because I know that Charlie was coming home with some of this stuff in pre-algebra. But I know we for sure did it in algebra. So this is good review for lines. What's the y-intercept of that line? 3. What's the slope? 2. So I'm going to start here at 3, and a slope of 2 means I'm going to go up 2 over 1. I am going to make it a solid line. So this time my plane is cut in half on a slant. I like to label my line, so the line is exactly y equals 2x plus 3. So I'm either going to shade over here or over here. I am going to test a point. You can test any point you want. Let's say I tested this point. What are the coordinates of that point? 1, 1. How you test a point is you put 1 in for x and 1 in for y, and you see if it's true. So is 1 greater than or equal to 2 times 1 plus 3? Is that true or false? False. So that means 1, 1 is not in the solution. I'm not going to shade on that side of the line. I need to shade on the other side. Okay, are there any questions on half planes? All right, so let's move on to systems then. Bless you. And I'll start with, sure. Bless you. What's that? You're allergic to blueberries? Hope not. Not swelling up or anything. All right, so I'm going to show you then a graph, how we do something that's nonlinear. Okay, so really today, fair game are all of our basic functions so far. So we have mostly like parabolas and lines you'll see. I had some parabolas. I is greater than 2. Okay, and then I can fit 2 on a page, I think. You don't have to do what I do, but okay. So I'm going to put my XY axis on here. And I'm going to assume that this is a scale of 1s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like right there. So the top function is a parabola, isn't it? Tell me what you know about that parabola. What's its vertex? 0, -3. Yep, it's like a parabola moved down 3. So I'm going to make it have a vertex down here at 0, -3. And the thing that I know about parabolas is that if I go over 1 the first time, it goes up 1. And then if it went over 2, it would go up 4. If I went over 3, it would go up 9 because it's squared, right? So I'm going to at least graph a couple of those points. So I'm going to go over 1, up 1 from the vertex, over 2, up 1, 2, 3, 4. Or simply just put those points in the equation. And I'm going to make it a solid parabola. I still have to use my rules for it's solid if it's a greater than or equal to or less than or equal to, and it's dashed if it's not. Okay, so that's good enough for that. Now, if you were to extend these lines, okay, the shading for the parabola would either be kind of in this interior or on the exterior, okay? So I'm going to show my little trick. I'm not going to shade to the end, but I'm going to pick a point, that one. I'm going to pick 0, 0 because it makes things cancel and it's a nice one to work with. And I'm going to put it in for X and Y. So I'm going to show my test right here. If I tested 0, 0, I would get the inequality 0 is greater than or equal to -3. Is that true or false? True. 0, 0 is on the interior of the parabola, so in a second, don't do it yet, I'm going to draw these little arrows to remind me I'm trying to stay on the interior of that parabola. All right, let's graph the line. Tell me what you know about the line. Anything you know about the line? Y-intercept is 2. What's the slope? 1/2. So from the y-intercept, I should go up 1 over 2. And is this a solid or dashed line? Dashed. I'm going to test the point for my line. 0, 0 is below the line, right? I put it in. 0 is less than 2. Is that true or false? True. So I want to shade below this line. Now, when you're trying to find the solution to the system, you want to only shade the overlapping region. So I need to stay inside the parabola below the line. You're going to shade right in this region right here. Questions on that? Okay, if you want to take a moment to move that in, you may. You don't have to, but I'm going to. Second. All right. So I'm going to give you one that's linear now, and I'm going to just show you something in standard form because I think some of us might have forgotten how to graph things in standard form. So I would like us to graph 2x plus y is less than or equal to 10. 2x plus 3y is less than or equal to 12. X is greater than or equal to 0. Y is greater than or equal to 0. Okay. So let's take a look, please. And these are all lines, correct? Now, who remembers what this means? X is greater than or equal to 0, y is greater than or equal to 0. Anybody? Where is this located? Which quadrant? That's what I'm getting at. If I said x is greater than or equal to 0 and y is greater than or equal to 0, that means I'm going to only graph it in one of the 4 quadrants. Which one? 1. I'm not going to even draw the whole plane. I'm going to just draw quadrant 1 then. So I'm really done with that part of the inequality by just sealing that off. All right, so I absolutely know that you can change these to slope-intercept form. That's one way you can do them. But sometimes it's helpful to find the x-intercepts and the y-intercepts. Maybe your math teacher taught you some point. To graph a line, couldn't you just plug in a point and find the other point? Can't you do that twice? Okay, so what I'm going to do is I'm going to mix it up here, and instead of having these in slope-intercept form, I'm going to put in 0 for x and figure out what y is. If I put 0 in for x, it cancels, right? What would y equal? 10. If I put 0 in for y, let's flip it around, what would x equal? I get 2x equals 10, x would be 5. So I'm going to graph this line by using the point 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5, 0. And then I just connect those 2 points. Is this solid or dashed? All right. While we're here, let's do our test. If I put 0, 0 in, wouldn't I get 0 is less than or equal to 10? Isn't that true? So in a second, I'm going to be shading below this line. All right, next one. If you put 0 in for x, you tell me what would y be? 4. If we put 0 in for y, what would x be? 6. So 2 points that are on this graph are 0, 4 and 6, 0. This is also a solid line. When I test 0, 0 on this one, I get 0 is less than or equal to 12. Is that true or false? True. So where should I shade? Below. So I want to stay below both of these lines. So the area in which I'm going to shade the overlapping region is going to be this little quadrilateral. Ooh, haven't heard that word in a while. This little quadrilateral closest to the x-axis. Okay. Okay, what do you want to try next? Circle and parabola or circle and line? Okay. Can I turn the page? This is a good reminder. In general, the equation for a circle with center 0, 0 is x squared plus y squared equals r squared. Do you remember what r stands for? Radius. So I'm going to make one up on the fly. Sometimes that doesn't work well, but I think I can do it. We're going to graph x squared plus y squared is less than or equal to 16. And do you want the line in slope form or standard form or slope-intercept form? What do you need more practice with? The standard form? Okay. So I'm going to do x plus 3y is greater than 9. So for the circle, you're going to have to just do the best you can to draw the circle. It has a radius of 4. How did I know that? Yeah, square root of 16 is 4, and a center of 0. So if I'm graphing it, it should go through 1, 2, 3, 4, 0, 0, 4, negative 4, 0, and 0, negative 4. So we're going to try to do the best we can. Oh boy. Oh, I was doing so good. Right there. Okay, so this is the circle. All right. So let's test. So on a circle, we are either the solution's going to be on the interior of the circle or the exterior. We test 0, 0. And we get 0 is less than or equal to 16. So this is on the inside. Okay, here are our choices. If you want to, you could subtract x from both sides and divide by 3 and get it into slope-intercept form. Or sometimes I think it's easier just to plug 2 points in. That's what I'm going to do. So I'm going to put 0 in for x. What's y? 3 times what is 9? 3. I put 0 in for y. Ooh, I don't even have to do any work there. What's x? 9. Okay, so this is dashed. I test my point and I get 0 is greater than 9. Above